Guys, good evening. Um, we will buy some time, at least 5 minutes, for people to tune in. Thank you for joining in good time. In the meantime, you can let me know whether you can hear me. Just give me a thumbs up if I'm clear, if I'm loud and clear. Right. So we'll buy the 5 minutes as we wait for quorum. Hi guys. Good evening once again. I hope you can hear me. Yeah, without taking much time, I'd love for us to start. I'll start by introducing myself. In the meantime, you could introduce yourselves on chat. Let me know where you're joining me from. Let me know where exactly you are in your career journey. Are you a beginner? Are you an intermediate? Are you in your advanced level? Just let me know what level you're at. It will really help us to know what direction we are taking on this call. So feel free to introduce yourselves. I'm looking forward to see your responses on chat. I will go first. My name is Grace Mutinda. I handle community management at Zindua School. This webinar is organized by Zindua School, and we're going to take you through um, how to go about interviews, especially technical interviews, and why you're not getting passed through them. And we're also going to be able to handle any questions that you might have. So I'm hoping you have come with questions that you might need clarity on. So I want to see on chart. I can't see any responses yet. Okay, I can see Gabriel Harris has responded, software developer, 7 years of industry experience. Thank you for tuning in, Gabriel. The rest, I'm also waiting on your feedback. For those just joining, thank you for tuning in. We are still on the introduction bit. As you join, let me know on chat what you're doing and where exactly in your career journey you're at. Are you a beginner? Are you an intermediate? How long have you been in the industry? As you do that, I'm going to shift to a new tab over here. I want us to do a fun game, and I'm going to be awarding the top people who are going to be on the leaderboard. For the people on the leaderboard, I'm going to be giving discount for our upcoming DSA course. So ensure that you are on the leaderboard. For don't worry if you're just a beginner in the industry. I have tried to make the game as simple as possible. So try to answer all the questions. Kama you don't know some. So Wycliffe is saying he's joining from Kapsabet, Nandi, a junior dev intermediate, 1 to 2 years experience. Thank you for tuning in, Wycliffe. Daisy, software developer, intermediate, 3 years of experience. Thank you for tuning in, Daisy. Still waiting on the rest. I'll be sharing the screen on the game that I want us to do. As it loads, I will read incoming comments. Jerome is saying he's a beginner. Thank you, Jerome, for. Okay, so my game is loading. Just give me one more minute. And so Peter is saying he's a junior full stack developer, 2 years of experience. Thank you for joining. So I'm pasting the link to the game on the chat. Click on the link. I'm also going to copy the code on the chat as well. As I've mentioned, I will be awarding top 3. But based on how you perform, I'll see whether to extend to top 5. But I will be giving discounts to top people on the leaderboard. That is discount to our incoming DSA course. DSA is data structures and algorithms. So go ahead and click on that link, join the game, and I will start once I see at least 5 people. We actually 14 minus 2, that's 12 people on call. That is minus myself and the speaker for tonight. So just I'm waiting for you. So join and then I will start. Okay, I can see 3 people. I need some more before I start it. For those who just joined, let me repaste the link for your sake. If you're just joining, we are doing a game. It's not a hard game. Just join. If you make to be among the top people, you're going to get yourself a discount to the course. Right, 1, 2, 3, 4, 5, 6. Okay, we are at least 6. Can the number increase? We are 13. When we get to 10, but in the meantime, I'm gonna start. For those who just joined right now, good for you. Can start the attempt. Right, I've just started the game. So let's see who makes it among the top. Okay, I'll repaste the link over there for anyone just joining. There is the link. We get to join the game and there is the passcode. So I'm going to stop the game in exactly 4 minutes. So be quick on your attempt and be sure to what you're answering as well. The competition is quite stiff. You can see the leaderboard changing every 2 minutes. Okay, I can see 2 people done. Waiting for the remaining 7. You have 2 minutes. Okay, we have 5 people done, waiting for the remaining 4. Okay. Wow, 2 people left to complete, waiting for you. 1 minute, 1 more minute. Right. Perfect. I'm going to end it at that. Let's see. Okay, so we have Peter Harry taking the lead at number 1. And then we have Anthony taking it at number 2. We have Crispinas at number 3. We have Lewis at number 4. Wycliffe at number 5. Patrick at 6. Gabriel at 7. And Alfred at 8. And Daisy at 9. Thank you for attempting. I will communicate shortly what's next for the winners and how to redeem your discount for the course. So without further ado, I want to shift now to the session. So once I'm done introducing the speaker for today, I'm going to communicate with the winners how they will redeem their discounts. I hope you can still see my screen, I believe. Right, so we are going to handle why developers struggle in coding interviews. That is common mistakes that are made, the problem-solving approach, and how DSA comes in to help in the technical interviews. We'll have a short demo or a walkthrough through a real life scenario where you could handle problem solving. And then finally, I'm going to talk about our incoming program, that is DSA, and then we're going to handle any questions that you might have. So we've done the engagement activity. So allow me to welcome our speaker for today. His name is Charlie. He is a software engineer with 8+ years of experience. He is a security research and exploit developer. He is in the security research and exploit development area with 9+ years of experience. He's a student and a ratified CTF player. He says he also loves assembly. He's gonna talk about more about himself. So without further ado, allow me to hand it over to Charlie. Charlie, I hope you can hear me.
On a scale of 1 to 10, how audible am I?
I'd give you an 8. Your volume sounds a little bit low. I'm not sure if it's mine.
Let me see if there is any.
Okay, I can hear you now.
Okay. All right, cool. All right, so I have already been introduced. My name is Charlie. I'm both a software engineer and security researcher, and also an exploit developer. I used to play games called CTF or Capture the Flags, but uh, of late I've been having like a lot of work, so I barely play them in as much as I would love to. I do play them, and I really love ARM assembly. So ARM is a programming language that you use to speak natively to specific types of computers. So today we'll be seeing on why most of us, or most of us, usually are blunt or blunder in interview, especially coding interviews. Now, from the context that I'm going to take, is from some of the known companies like Microsoft, Safaricom, and Google. So when they are hiring for any software dev, be it a front end developer, uh, a backend developer, or any other sort of developer, they usually give you a coding challenge. And in most cases, if not all cases, these coding challenges are usually DSA oriented. Now, before I begin, I see some of you had sort of typed um, on the chart on the skill level on the level of experience. I would like if the rest sort of typed the same, just so that I can know how I'm going to introduce this in a manner that everybody understands. I don't want to introduce something complex that only the team understands. I want to bring in something so basic that everyone is like, that's so basic. And I don't want to bring something intermediate when we have people across all the lands. So if you don't mind, please type in the chat on the level of experience you have in software development, if you're a beginner, if you've never coded before, if you have some basics in programming, if you have been coding for 20 or 30 years, something of that. So just type it on the chat, and then we will proceed from that. All right, I can see some activity. Keep it coming. I just need to know the level experience. So ideally, so far from what I've seen, we mostly have beginners to sort of intermediate-ish, something of that sort. And I believe for such people, ideally, most of you should be able to sort of um, be comfortable with basic programming language like maybe Python. So I will base what we'll be learning on Python, but we can use any other programming language like maybe Java or assembly if you would like to, or even JavaScript. But just to have a common ground, we're going to be using Python. So I think that's actually sufficient. I already can see or weigh in on what we're going to sort of handle. I think that's sufficient. So let's begin. Now, why do I would use beginners, but it falls across all these levels. So why do most of us usually fail in technical interviews? And by technical interview, I mean were you given a challenge in maybe HackerRank or Codility or whatever those platforms are, and then you're supposed to handle it. Now, in most cases, when you're building an application, either as a front end or a back end or a full stack developer, usually have time to go through documentation, test ideas, create your own scripts, read error messages, ask questions to teammates, and something of that sort. Okay, just to see how you can improve your code. But in an interview, you are mostly expected to solve a problem, first of all, quickly. In most cases, someone is watching and harshly judging you, and also judging your thinking. So in such a context, you have to weigh in between thinking, what you're saying, and also what you're doing. And this, in most cases, gives people pressure. And in as much as you're like a good developer, you can forget some really basic logic. Okay, so the big difference in doing software development on a normal day and doing it when having an interview is when you're building an application in a normal work day, you're using frameworks like, I don't know, React and Node.js or whatever. You're using tools that have proper documentation, something you can go and read what does this do and then have a proper implementation. But when you're solving interview problems, you're ideally breaking down a problem and then choosing the right data to use. That's very key, choosing the right data to use, and the structure and the algorithm, and also how to explain and reason what you're doing clearly. So, I'm going to give an example of a front end developer. All right. You might be really good at maybe React. Okay. You do React on a daily basis. You're a Jedi Pro Lead Master when it comes to React. Okay. You also are good in creating Django APIs, and you can make the React front end and the Django communicate. Right. And maybe let's say you're also like really good when it comes to creating mobile applications using maybe Flutter or some other programming language or framework. Okay? But in an interview, you are asked something like, given a list of numbers, find maybe something. So that doesn't fall exactly into like a niche area like React or Django or Flutter. It's something that cuts across, and it's basically testing how you're going to reason and break down the problem. So common mistakes that most people usually do is like to start coding immediately without even understanding the problem. And in most cases, these problems are usually tweaked in a manner that is interestingly tricky. So when you just dive into it without breaking it down in your head, or maybe taking some notes, or just breaking down in some way, you will get a difficult time when you start like diving into it. So the first thing you have to do is understand the problem, like clearly understand the problem. You can stay you can maybe take like the first 3 or 4 minutes to just understand the problem, okay, without a rush, having a clear head, and then just processing and understanding the problem. Now, the second mistake that most people do is doing or handling or solving the problem when you're silent. So this is in a context where you're having somebody judging and invigilating you. In such a context, you need to explain your thought process. However messed up it is, you need to be able to explain your thought process. And this is sort of comes with some practice, because some of us are horrible at multitasking. Okay, you'll find like you're writing what you're saying, or you're saying what you're thinking and something like that. So you need to be able to balance, like whatever you're typing, you're able to explain your thought process as you're doing the typing, or you can explain and then type, or the other way around, you type and then you explain, but don't be silent when you're doing this whole thing. All right. Then another mistake most people do is to think that your answer is the only final answer, or just think of the final answer. Okay. So, in most cases, and especially in programming, there are so many ways you can solve a single problem and have the same answer. So, you might have a problem that has maybe 10 or so approaches. If you want to generate a random number, maybe in Python you can use random, you can use your own logic to listen to maybe keyboard movements and then generate, just some random numbers. Like there's so many ways that you can use to solve a single problem. So that doesn't mean that the answer that you arrive to can only be arrived to with that specific approach that you used. Okay. Then in most cases, we ignore edge cases. So you're just thinking of like a straight path. You don't think of some possible things that could arise in the middle. And this usually is a problem, especially for software engineers. When you're creating a system, you don't think of creating something that just works. You need to be able to think, when this thing works and then it gets maybe like 10 million users, is it going to be able to handle those users? So you must be able to think of the edge cases that don't just think of like the solution. Think of maybe if it's a calculator app you're told to build, what happens if you add two negative numbers, or what happens if you add a string instead of a number? Something of that was something that is not ideally in your path of solving the problem, but it's an edge case. Okay. Another problem that uh, when we are handling such, we usually get through, is using brute force. Okay, so you brute force to get to the answer, but you do not think of like an improved version of what you're creating. So you just think of, I would call it cooking. You cook your code so that it arrives to the answer, but not thinking of how you can create something optimized to get to the answer. Okay, and also something that is naturally human, you panic. So when the interviewer maybe gives you a hint, they tell you, try this or that, you'll be like, oh my god, am I doing the wrong thing? And I think I messed up or something like that. Don't panic, just calm down, try to listen what they're saying. They might actually be tuning you to the correct path or something of that sort. Okay. Then um another thing you might sort of do wrong is fail to analyze time and space complexity. Now, you will understand this when you have proper knowledge in data structures and algorithms. We have something called the big O notation. Okay, so when you're creating a solution for a problem, you think of the most efficient way that doesn't use a lot of memory and doesn't use a lot of time. Okay, so it uses the least memory and it's also fast. So that creates something that is very efficient. Okay, so when the interviewers are giving you these questions, what they want to see is not how you arrive to the answer. They want to see your problem solving approach. Like, how do you think about logic? Okay, are you interactive? Do you ask questions? Do you think of do you think outside the box? Something of that sort. So they test your problem solving approach. They test your communication and thinking skills. Like when you're typing, are you able to explain what you're doing, or you just like randomly spewing garbage? Okay, and then they also test your efficiency. Is your code efficient enough? Like, are you able to create something super efficient? Because in most cases, when we're working with systems, we have limitations in both memory and storage space. Okay. Then they also want to see if you're able to recognize patterns. If you see a pointer, can you be able to tell this is a pointer? If you see a hash map? Are you able to tell this is a hash map? If you see a stack, are you able to see a stack? Or if you see a problem that requires any of those that I've mentioned, are you able to correlate that this specifically needs this specifically needs this, something of that sort, right? So they want to see if you're able to recognize patterns. Now, with all that in mind, you have the question, why does DSA matter, like in all these things, and why do they bring contextual questions related to DSA in interviews? So I might have been using the term DSA, and some of us don't know what DSA means. So DSA is sort of short form for data structures and algorithms, right? And data structures basically are a way to organize data. Okay, so we know the basic data types in most programming languages, like strings, numbers, arrays, something of that sort. But then we also have complex data types that are usually shared across most object-oriented programming languages. Okay, we have things like trees, we have queues, we have sets, we have trees, we have heaps, and so on. So all of those are data structures, because something like a single number, be it a million or 2 million, it can be able to store more than one specific data type. Okay, it can be able to store a string and a number at the same time. It's only designed to store one specific data type. But when you have a data structure, like maybe an array, you're able to store multiple data types in that array. Okay, so um, in so that's an explanation of what a data structure is. Then comes to an algorithm. An algorithm is essentially a way, or let's think of it as like a step-by-step method of solving a problem. So in most cases, and this not only applies in programming, when you have like a really huge problem or a really huge task that you need to handle, you don't handle it as the whole sum. You break it down into smaller bits, and then break those smaller bits into other tinier bits, and then you're able to handle them individually just to create the whole thing and make something beautiful. That's why even when you're learning programming, you start with really tiny bits of programming. You learn what is a data type, you learn what is a variable, you learn something like what is a loop, you learn something like how you maybe how you use an if statement, something of that sort. And then eventually you conjoin or you combine all those to create something beautiful, like a program that um, listens to a keyboard, press and then does something interesting, something of that sort. So you sort of when you're solving a problem, you reverse the process. You see, when you're learning programming, you learn those tiny bits to create something huge. But now when you're solving a problem, you break down the big problem to those smaller bits that you did learn, and then you piece them together like a Lego structure, and then you create something beautiful. Okay. So an algorithm is a step-by-step method of solving a problem. And for any problem that you will ever face, even in real life, like you're told to build a Tesla car, if you just go to Google or YouTube and then just Google for how to build a Tesla car, you will end up in a rabbit hole. You will barely find any relevant resources. But when you break down that problem into smaller bits, like maybe how to fix or how to build a Tesla car wheel, how to build a Tesla car seat, you will find relevant solutions. And then when you build all those small pieces, the wheel, the chassis, the axle, the whatever, you can then conjoin them or combine them together to create or to build a full Tesla car. But when you just go even to these AI models and then ask them to, create a full, I don't know what, with this as a software engineer and all that, it will probably at some point give you some garbage. But when you give it piece by piece instructions, create a variable that does this, create this that does this, and then you piece them together, or you tell it to piece them together, you create something beautiful and amazing, right? That is not some piece of hallucination. All right. So That's data structures and algorithms. Now we have something in algorithms that you need to know about, which is more of efficiency. So when you're learning about data structures and algorithms, you also learn in the process how to create efficient systems. Okay, I said in most cases you usually have constraints when it comes to time and memory and space. So you might have a really good software, but it requires like maybe 1,000, not 1,000. Let's use something realistic, like maybe let's say 64 gigabytes of RAM. Not all. Let's assume it's a mobile application. If a mobile application that you have created uses 64 gigabytes of RAM, that's not a typical or a usable software, because most devices or most devices that we have available right now have memory limitations that get up to maybe at most 8 gigabytes, 16 gigabytes, only for the flagship models that can get to 64 gigabytes. Okay, so when you're creating your software, you make sure it uses the least amount of memory available, so it also doesn't make the phone lag. Same thing for laptops and servers and all these other machines. Okay, so um, uh, that's it with the DSA necessity on optimization, on giving you the ability to think about algorithms, being able to recognize patterns, and all that. Now, um, the 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 thing that DSA does is it helps you in these technical interviews a lot, because one, most of these interviews will have context around data structures and algorithms. Okay, because most people think of DSA as this hard thing. I think that was the same mentality that I had in mind. Hearing terms like big O notation, I'm like, what the hell is that? Okay, but when I got to understand what it is and how it works, or how sort of you use it, I was like, this is actually something simple. It's the same context. Most people say programming is really hard. Okay, it's really hard. They treat programmers as these geniuses and all that, and then you get to learn Python, you'll be like, oh god, this is just some English on steroids. Okay, and you'll be like, this is actually simple stuff. Okay, but when you're starting out, it might seem hard and all that, but with time and practice, it becomes very easy. Something that you can just, think and just get it flowing in your fingers. Okay, so DSA helps in most interviews because, as I have said, most of these problems are usually designed around common patterns like um, instead of seeing each problem as like a new thing, when you read it and you have DSA context in the background, you start thinking of the correlation between the problem and what it needs. So you read the problem and be like, this needs a hash map, or this needs to be sorted, or this needs like a search algorithm, or this needs a stack, something of that sort. So if you do not have context in DSA, and you already are good with maybe arrays, and you've seen what lists are, you cannot be able to correlate the relationship between these two things. So you might be a good programmer, like the best, but when you're given a data structure and algorithms problem, you find that you're a dumb. It's basically because you do not have the contextual link, or like a way to link a problem or a DSA problem with the knowledge that you have. So essentially, if you're a programmer, you just need that tiny push into data structures and algorithms, and then you'll be a Jedi ninja. Okay, you'll be razor sharp when it comes to handling most of these interview problems. So if you have DSA context or knowledge, it makes most interviews less scary. Okay. Now we have two ways of thinking. Okay, not two ways. Let's say we have a junior way and a mid-level way of thinking. In most cases, you will find junior developers thinking in something in the lines of, how do I make the code work? Okay, so their main focus is making code that works, right? A mid-level developer would be thinking, how do I make correct code that is readable, efficient, and scalable? Okay, so that's how like a middle level developer thinks. And then a senior level developer would be thinking, how do I write code that is readable, efficient, scalable, and yeah, I think I've used all of them. Readable, efficient, and scalable. All right. So um, you would find that when you give a junior person a problem, they would give you a generic answer like, I used a loop and then I got the answer. You see, that's so it's correct. It's a correct answer, but it just touches the surface, right? When you get to a middle to senior level developer, they would give you something in correlation to the big O notation. Okay, so they will tell you something like the brute for a brute force solution is maybe O of n squared, or maybe it works with small inputs. But when we can further optimize it to O of n, something of that sort. See, like they are correlating their code into how efficient it is, right? So that's the difference between a junior level developer and a middle to senior level developer. And that bridge can be sort of, that gap can be bridged by having context around data structures and algorithms, because that's where you get to know what the big O notation is, how you apply it in real life situations and something like that. So, okay. So I have been mentioning this big O notation. Okay. Maybe I have explained at some point what it is, but it's basically a way to describe how an algorithm performs as the input as the input grows, or as the input gets bigger. All right. So think of it in this way. If I'm giving my code maybe just two inputs, is it going to behave the same way as I give it like maybe 2 million inputs? All right. So it's a matter of scalability, right? So it does not literally measure the code execution in seconds. It's sort of measuring how efficient your code is when the number, or when the size of the input grows, right? So without further ado, let's get into like a typical interview question and then handle it. But before I get there, I will open room for any questions into what I have sort of gone through around interview questions, why we think of them as being hard, and it's something of that. So any questions around that context before we get to like a practical maybe demo or something of that sort? Any questions? All right, so I'm going to share my screen, and let me pop up a question that is not too difficult, that is not too simple. It's just there in between. And then we're going to break it down and see how someone without a DSA context in mind would solve it. And also how someone who is skilled in these data structures and algorithms would go about it, and also explain the downsides, the thought process, something of that sort, and how you might go about this if it was a real life typical interview. So let me share my screen. Okay. I hope my screen is visible to everyone. You can confirm with a thumbs up if you're able to see my screen. Awesome. All right. So this is a typical technical interview question that you might be given. So as I was beginning, I gave context that some of these questions you'll usually get them through platforms like Codility or HackerRank, and in other cases you will have a panel that you maybe are explaining to how to handle such a problem. So you might have like automated software, or you might have individuals that are judging you on the go as you think about the problem and sort of handle it. So I'm going to solve this problem in two ways, right? So I'm going to solve it in I don't know if I can use Junior. Um, Let me solve it in I would I would call it a naive, not naive. I don't have the exact word that I can use, but I'm going to show you how you can handle this as a normal person. Let's use normal. How you can handle this as a normal person, and how you can handle this with DSA in mind. Okay. And the DSA way is sort of the best way or the most efficient way that is going to entice, if it's an automated software like HackerRank or Codility, it's going to get you the if it's max, the full max. If it's if it's an individual, they're going to see that you have proper logical and thinking and problem solving skills, right? So in here we have a question. So it's telling us that we are a developer and we are building an online shopping system. All right. So as I said, you first have to understand the question. All right. Um, okay, I can see Audrey saying their screen is blank. I don't know if that's the case for everyone else. If it's only Audrey, I think you can exit and then rejoin. Might be a network issue. All right. So we said we first break down the question into pieces that we can understand, right? So the first thing is the context. We are a software developer, so it seems like it's a real life problem. Okay. And we are building an online shopping system. So this is a problem that you might actually face. Either you're building a solo product or you're in a company and you're working on something like this. Okay. So the question is, we have a customer here with several gift cards, okay? And each gift card seems to be having different balances, all right? So before them checking out, um, our system needs to know if the customer can use exactly two gift cards to pay for the purchase. All right, so our task is to write a program that checks whether any two given gift cards balances add up to exactly the same purchase amount. All right, so explaining this when you read a problem like this in your mind, for you to better understand, you can think of it in the most layman language as possible. Okay, don't think of it as a programmer. Think of it as like a typical client or a customer, right? You know, a customer won't be able to use logical programming sort of context. So you think of it as the person facing the problem. So let's assume we are a customer and we have maybe 10 gift cards, okay? And each gift card has a specific value. So normally, if we wanted to know like if any two gift cards can be able to purchase something and we will get to input zero cash and only use gift cards, we just need to add them add the gift cards manually and then see if any of them will give us an amount that we can use to purchase an item. So I think that might have complicated things. Maybe we can use this example that they have given here. So in here, we have how many gift cards? We have 4 gift cards, and each gift card has a specific value, all right? And the thing that we want to purchase, let's use the Kenyan shilling. The thing that we want to purchase is 17 Kenyan shillings. So we want to check if we can combine any two random gift cards, and then the total will be amounting to 17, so that we can buy the product without inputting any money, uh, on using gift cards. Okay. So this is something that we could handle manually, but in the question we have been told to create a system that automatically calculates this. So you just give it the number of the gift cards you have, maybe in an array, and then you tell it you want to purchase a product of this amount, and then it will find which 2 gift cards you can use to purchase this product. Okay. So this is what expected software should behave like. If you give it the gift cards and the amount of the thing you want to purchase, it will give you if you have 2 gift cards that can purchase that product, which is true or false. All right. So in here, if it gives you true, you have to know why it gave you true. Now this is because we have this gift card with value 10, and this other gift card that has value 7, and they amount to 17. All right. So baseline is we can do this manually by just adding 10 to 17, but we want to do it programmatically to go through the array. So this is just an example that can be easily manually handled, but think of it as like you have maybe 1,000 gift cards, right? It's very difficult for you to go through all those gift cards, adding the values to try and find if you have any two that would match up to give you that specific amount that you want, right? So yes, I'll be able to share this after the call, so you don't have to worry about that. All right. So we have understood the problem at this point, in that we are given a list of gift cards, okay, a list of gift card balances, okay, and we are also given one purchase total. So the question, if we have to break down all this jargon into one specific single question, is can we pick any 2 gift cards, any 2 random gift cards that will add up to exactly the amount that we want, that will add up to exactly this purchase total? That's the simplest way to break down all this question into like one sentence that is easily understandable. Can we pick any random gift cards that will add up to this total that we have been given? All right. So we are not trying to use all the gift cards at once. That's the first thing. We are not trying to find the best combination. We just need one specific combination of 2 values that will amount to this. All right. So thinking in a programming sort of approach, or maybe even starting with manually thinking out this problem, is if I add 10 to 15, that won't amount to 17. If I add 10 to 3, it still won't amount to 17, right? If I add 10 to 7, it will amount to 17, but this is because there's a simple array. You might find that the solution that we want will probably be 10 here and the 7 here. Or maybe we have, I don't know, 6 here and 11 here, right? So we just need to, in this array, find a combination of any 2 random gift cards that will amount to the total that we want to purchase, right? So the most natural way, which I was talking about, let me just have maybe here, can we call it the naive? Or the most basic approach, okay? The naive way. The naive way to solve this is to first of all think of it as we take the first gift card, so we'll take 10, all right? And then compare it with all the others. So we'll start with 10, add it to 15, and then we compare it with 17. Then add it to 3, compare it to 17. Third, add it to 7, compare it with 17. That's the most basic uh, way we can think of this. And then when we are exhausted with all that and we do not find the answer, we go to 15. We take 15, add it with 3, and then compare with this 15, add it to 7, compare it to this, something of that. So we'll do that up to when we have like exhausted all the numbers and all the combination. Now, that is usually called the brute force approach because you're ideally brute forcing the values, right? So, okay, just a minute. Sorry about that. I just spilled some water on my table, and water is very horrible with electronics. Okay. All right. So that's the naive, or we usually call it the brute force approach. Brute force approach. Okay. And it works. That's the first thing. It's going to work, but it might not be the fastest or the most efficient. Okay. But either way, if you don't have a BSA background, this is definitely what you're going to fall for, right? And it's going to work and you're going to explain everything. So um the idea is we check every pair and then keep moving to the next up when we find a pair that works, right? So let's create some basic script in Python that does this sort of in a brute force way. So I'm just going to create some script here in Python, and don't worry, it's not going to execute in here, but after we are done sort of thinking out the solution to this, we're going to run it in some Python file and then see if it works or it doesn't work on something of that sort. Okay. So the first thing that we need to do, again, we are assuming we all know some basic Python, or Python is sort of like English on steroids. So even if you have zero programming knowledge, you should be able to understand what I'm doing here. So the first thing we do is create a function, and in Python you create a function using def, okay, and then the name of your function, okay. So we can call our function what we want it to sort of do, right? So we want to create a function that is going to check if we can pay with 2 gift cards, right? So we can call it something like can pay with 2 gift cards. All right. So if you're doing the interview, if you're doing like the interview, you do something of this sort. This is not a realistic function name, but at least it tells your interviewer that you know what you're doing. All right. You know how to name functions in names, or in names that correlate to what the function is intended to do. All right. So you create a function like that, and this function is going to be taking 2 inputs, right? So the first input is going to be the gift cards, right? So you could call it gift cards, or you could call the first argument gift card or cards. So we can just call it cards, right? And then the second input that it's going to take is the purchase total. So you can just call it the total, right? So you can just call it total. All right. And then now we can get into the logic of how we're going to handle this. So Python is usually tab sensitive. I would call it tab sensitive. It's sensitive when it comes to indentation. So I'll use tabs for now. I will use some autofix later on in maybe my IDE or something of that sort. So the first thing that we want to do is create a for loop that is going to loop through all these cards. Okay, it's going to loop through all these cards. So if you have some programming background, you definitely know what a for loop is. And a for loop in Python, in most cases, usually looks like this. So we create a variable I that is going to somehow figure out how long this array that you're passing in the cards is. So we could use something like range. So range in Python is a function that generates a list of consecutive numbers. All right. So we're giving it range, something of this sort, and then in here we're going to use the length of this array. So we have a function called len, like this, and then we're going to use cards in here, something of this sort. All right. So ideally, to break this down into the easiest way that we could understand is we are looping through each gift card one by one. Okay. So when this for loop executes the first time, it's going to have I being 10. The second time, it's going to have I being 15. The third time, it's going to have I being 3. And the last time, it's going to have I being 7. That's basically what we are doing in here, just looping through this array and then having each individual number stored in this variable every time this loop executes. Okay, so that's the first thing that we're doing, just looping through and getting these numbers. Then the second thing that we want to do is create another loop. So whenever you have two loops in this way, we usually call them the outer loop and the inner loop. So this first loop will be the outer loop, and then this other one that I'm going to create is going to be called the inner loop. And what the inner loop is going to be doing, the first time this for loop gets to have this as the first number, the inner loop will now take the next number. Okay. So when this loop has executed, it will have I being 10. But the inner loop that you're going to create, the first time it's executed, is going to have the variable that you're going to be created as the second one. So let me just type it, and then I'm going to better explain it. So we create another loop. We can use a variable j, and then use the same thing, range. Okay, range. But now this time, instead of just checking using the length, we'll still use the length of the cards. But when we're generating the range, we use the number that we are at plus 1. Okay, so let me just do I plus 1, like that, and then we just get the length of the cards. So what ideally happens here is when this loop runs the first time, I is going to be taking the value of the first number in here. All right. But when we run this, it's going to take the first index, okay, for I. So when we run this, it's going to take the second index, which is going to be the first index plus 1, which is going to be the second index. Okay. So I really don't know how I can best explain this to, like, the most basic thing that I can think of. But thinking out loud is, when this loop runs, it's going to get the first number. When this loop runs, it's going to get the second number, something of that sort, right? Then after that, we could basically add these two numbers that we have extracted from the array and compare them to the total, as simple as that. So let's get here, and then also have an indentation here. And then we can use an if statement. So we can use an if to check if the cards, so if this array, and then we get the specific index. So we can get, let's start with I. So what is happening here is we are getting the first index, which will be the value 10. So this is going to, when this code runs the first time, this is going to have this 10. Okay, it's going to be in this cards here. All right. And then we add that 10 plus the same thing, cards, but now this time with this loop that ran and got the second index. Okay, so it's going to be cards plus cards and then j. So what is happening here is this range just gives you the index. It will start from 0, 1, 2, and so on and so forth. So the first time this runs, it will have the first index, which is usually 0. So I'm using this in the context that we have programmers in here. They know that usually count from 0. Okay. So it will get the first index, which is 0, and then that will be 10 here. All right. And when it gets here, this J will have this second index. So we will have 15 here. So what will happen when this runs the first time is we will have 10 plus 15. And then we check if this is equal, to this total that we passed here, something of this sort, all right? So if this is equal, if like 15 and 10 is equal to this 70 that we passed here, then we just return true. Okay, so we can just come here and return true. Okay, in Python, I think true is usually capital T. So we return true, something of that sort. And that will be the end of that specific part. But if that's not true, then the loop will keep on running. Okay, it will go to the next number, which is 15. 15 will be stored in J, and I mean in I, and then it will go to 3. 3 will be stored in J, and then it will add 15 and 3. It will find it's not equal to 17. Loop again up to when it finds a number, that two numbers that when you combine them you get 17. If it doesn't find any, it will just return false. So let's have the part that will return false, and this should be outside this for the outer loop, the outer for loop. So in here we just return false. So if this code of ours exhausts, if these two loops exhaust the combination and they still don't find two numbers that add up to 17, we will get false. But if it finds any of them at any given point, we will will be given true. Okay. So that's what is usually or that's what is happening in this basic code snippet that we have created. And for the interviewers, you explain to them in such a context, okay? So they will know you know how to create, how to create function names, you know how to create for loops, you know how to create outer and inner loops, and you might still pass. But if they're looking for efficiency, well, for a junior level, you'll be able to pass with such a thing, okay? But for a middle level or an intermediate level, you might fail, not because you haven't produced an algorithm that works, okay, but because you haven't made it as efficient, okay. So let's now maybe before we sort of run this in an actual Python file and see if it works, let's see the best approach or the better approach that you could use to solve this problem that we have here. So that was the naive or the brute force approach. Let's create a better approach here. So we can just call it maybe just better approach. I'm not going to call it the best approach because maybe there might be actually a better or more efficient way to handle this. I'm just going to call it the better approach. Now, the idea is instead of checking every two numbers or every pair in this array, we could keep track of the gift cards that we have already seen, okay? So if our code sees 10, it's going to store it somewhere, and then it will be checking if we have any other value that when combined with 10 is going to amount to 17, all right? So you can start seeing that that is not the conventional way of thinking in terms of programming. It's sort of a more advanced way of thinking, right? And this is the better approach because if you had, like I said, 1,000 gift cards, checking every pair means that your loop, okay, in this instance, whenever you have two loops, that means in the big O notation, your code executes twice as slower as it would execute when compared to when you only had one loop. because we have this loop running and then we have another loop running inside. Okay, so when you get to learn DSA, you will understand how loops slow down your code and how you could optimize them by thinking in ways that need you to use the least amount of loops to start with, the least amount of maybe space to be used in something of that sort, right? So in this instance, it's a good solution. It should be able to work, but it's not the best because of the time complexity. We'll get to that in a bit, right? So as I have mentioned, the better approach is instead of checking every pair, is you take one and then you just keep on looking for if you have another value that you could add to it to amount to 17. All right. So maybe just to break it down again a little bit further, is assuming you took 10 and then stored it somewhere. You just need to check, if I do 17 minus 10, what value do I get? Okay, I get 3. And then you use a loop to check if you have 3 in this. If you have a 3 in this, that means you've already solved your problem. So if you think of it properly, it's sort of like reverse engineering the question. Okay, you already have an answer, you have one value, you're just checking for the other one that you could add to it to amount to this. So if you're creating an algorithm, you'll be checking like a value, like maybe 10, and then subtracting it to 17, and then finding if you have another value that you could add to 10 to amount to 17. All right. So for such a context, or for such a solving approach, you need to have DSA knowledge. Okay. So when you're learning DSA, you come across a specific data structure called a set. Well, it's a data type, I think, in Python, in Java as well. And I think it's also a data type in JavaScript, not quite sure, right? So a set is a data structure, data structure, just like the way we have arrays and lists and what we call these hash maps, key value pairs, whatever objects. We have a specific data type called a set. Okay, and a set is first of all very fast. Okay, when it comes to checking if something already exists, so it checks for uniqueness in a way. So instead of searching the whole array twice, if you're using a set, you'll only need to do it once. Okay, and this will make your code faster and more efficient. So let's dive into it and sort of handle this. Come on. So iPhone, right? And we're going to use the same function name, so we can just copy this, or maybe add better at the end, so we could have something of this sort. Define a function like that, and then we could maybe say this is optimized, so we could add an O there, or maybe just do optimized. Let's use optimized, something of that sort. And then we still take the same two things, the card and the total. So I could just copy this and then have it here, something of that sort. And then now this is where we start using the set. So we're going to create a variable. So when you're using sets, you first need to create an empty set. You see, if you're using a programming language like C or C++, when you're creating data types, you start by creating their placeholders, okay? But this is a foreign concept in Python. When you're creating a variable in Python, you just create it. But for something like C, when you're creating maybe an array, you need to define it and define its size, all right? So it's a similar thing with the set. When you're creating or when you're using a set, you first need to define the set. So let's tell Python to expect a set that you're just going to call scene. Okay, so you're going to call this scene set scene. And this is how you define like a set. Is it usually capital or small? I think it's small, like that. So at this point, Python expects to have a variable that is going to store like this set usage is good when it comes to searching for unique um values. All right. So then after that, we can create a for loop. Okay. And in this for this context, we're not going to use this range. We don't really need this. We're going to use the in key one. So for maybe let me not use card let me use these cards for card in cards. So what this essentially means is it does the same thing as this, only that you're directly moving through this loop, and instead of taking this value and storing it, like extracting its index in this way, you directly get that value. So let me just explain that in a bit. You see, for this, when you're looping through using the range, you use the indexes. This range will give you numbers 0, 1, 2, 3. Okay, it will give you a list of numbers. So this function range, it will generate just an array of numbers 0, 1, 2, and 3. Okay, and then when you use 0 here, you get 10. When you use 1 here, you get 15, something of this sort. So this will give you the indexes, but this directly gets you the values, and then they are stored in this card. So the first time this loop runs, it's going to be getting this 10 and then storing it in this card variable. The second time, it's going to get 15 and then storing it in this card variable. That time, get this, store it like that, like that. All right. So that's what this specific loop does. Okay. Then we get back to what we had said here. If we take the first value, which is 10, so let me just have this as some note here. If we take the first value, which is 10, all right, we just need to check if we have any other value in this array. If we have any other value in this array, in which when we subtract the final total, which is 17, let me just do this. This is going to give us 7. All right, something of this sort. So if we take the first value as 10, we just need to subtract it to 17 like this, and then check if whatever the answer we get is inside this array, something of this sort, right? So in this instance, if we get this card being 10, we're going to do some calculation here, some very basic calculation. We can create a variable called needed, or the value that we want. So this is this, okay? The value that we want. We can just say the needed value, right? And then we say it's going to be equal to this total, which is 17, total, minus this value that we have at this point, which is 10. So minus card, all right, something of this sort. So this is essentially what we have done here, all right? So we're going to say the value that we want is going to be 17 minus whatever we are looping through, okay? Something of that sort. Then if we can have an if check here. So if this needed value that we want, if this value that we get in this instance 7, if it's in this if it's in this set, okay? So if needed is in what would we call the set? If it's in scene, then we return true. Okay, we return true down here. So let me just take finish up, and then I'm going to explain something. Return true, something of that sort. Then remember, this set is empty at this point. Okay, So we need to be able to add these numbers, or we need to populate this set in a way. So what we do is we first of all check, okay, we do the mathematics, like we subtract that, and then we check if the value that we got here, if it's in this empty set, all right? If it's in this empty set, we return true. If it's not, then we come down here and then we populate this set, or we add that value that we had in this set. So let me just do this and then explain a bit. Add this card that we have here. So just breaking this down into step-by-step execution, this loop, we are going to get 10 in the first time. Like when this loop runs, we're going to get card as 10, all right? So we're going to come here and check if this 10, oh sorry, we're going to check if we subtract this 10 from 17, we get 7. So needed will be 7. Then we're going to check if 7 is in this set. It's not in this set because we haven't added anything to this set. So we won't return true. Instead, we'll go here and this 10 will be added in the set, all right? So that will be the first loop. The second time, we're going to use 15, okay? And then this 15 is going to be subtracted from 17. We're going to get, I think, 2, right? And then this 2 is not going to be found in this set as well. So it's going to be added here. So you see this set will keep on growing up to the point when we will find value in the card that when we subtract it, we get something that is going to be in the set, right? That has already been added to the set. And at that time, we're going to get true. And when we get true, there will be no need to continue with this loop, all right? That will be the end of our loop. But we're still not done. Outside this loop, if like we exhaust all the numbers in this array, we just need to return true. So outside here, we can come here and just return true. I mean false, sorry. Now, this is the most efficient way of handling this process using data structures, all right? You see in here, we use 2 loops. From even like a simple POV, this is going to take longer to execute than this, all right? So that's how we can handle that problem in those 2 different ways, right? And just to make sure like I have not written gibberish or I have not lied to you guys, we could just copy this and create a Python file and run it with the specific values from here and see if it returns true or false, all right? So I'm just going to open a new terminal and zoom out a little bit. Zoom out a little bit like that, get into the desktop, and let me see what do I have here. Okay, so in desktop, we can create a folder and we can just call it DSA. Then we can get into DSA and we can create a file. Let's call it naive. So let's call it naive.py. And then we can just paste what we have here. So I don't want to use VS Code. I can just use Vim because we're not doing a lot of stuff. So I'm just going to paste that code here. Oh, I hope that doesn't have the same that's broken. And then, oh, I have a typo here. It's supposed to be return false like that. And then we could call the function down here. So let's call the function. And before we call the function, we could define the card and we could define the card and the total. So let's have a variable here for these cards. And the cards will be this array like that. And then we could also have another one for the total. So the total was 17, all right? And then we could just call this function with those two. So let me just call it as is, just that, something of that sort. So assuming everything is okay, if I haven't broken the indentation, they should be able to give us true because we have two values in which when we combine them, we'll get 17. So let's just, oh, and we're supposed to print this. So we can just add print here. We could add a print here so that when it returns true, we'll be able to see it in the console, something of that sort. So let's just run this with Python naive.py. Yeah, and we have some indentation issue. Wait, is that an indentation or a syntax? Let me just check. For I in range. Let me try see if I could fix this in VS Code, the indentation I mean. So let me bring VS Code here. All right, so this is our problem. I'm just going to highlight everything. And oh, I don't have a formatter for Python. Just use this. Okay, so give it a few minutes. So you could see these squiggly lines. This means we have some indentation issue somewhere. So let me try to ident it again. Ah, come on, I thought I've already done that. Okay, let me fix this manually. I missed a very crucial thing here. Sorry. Yeah, this is not an indentation issue actually. I missed the in keyword for I in range. Okay, yeah, it seems everything is good. So let's try to run this again. And it gives us true. So this could be, it could be just hallucinating true. So we could try force it to have no answer, like to have no two possible values that can get to 17. And if it still gives us true, then we know we have messed somewhere. Now this is what we call checking the edge cases, right? So we could maybe change this to maybe 71, something of that sort. So in here, I don't think we have any two values that could amount to 17. That means it should give us a false. And that passes our test. So that means even if we give it now, even if we give it like 1,000 numbers in this array, we should still be able to get a value that when combined adds up to 17. So that was the naive approach. Okay. Now let's use the better approach. So you can just call it the better approach. We could just call it better.py. All right. And then we could just go. It's supposed to have an in here and another one here. So let's just copy this, paste it into our VS Code, and then we could have these two as well. Let's do variables, and then we could call this function wrapped by a print statement. So the same way it is, we just do print. and then we have that inside, something of that sort. Okay, oh sorry, something of that sort. So ideally, if this is properly, if we did properly ident, it should be able to run and give us a false. So Python better.py. Oh, we have an indentation issue, so let's fix it as well. Come on. Yeah, let me just fix it manually. Where is the issue? Let's see. Set. We have the fall here needed. So oh, this should be inside. Oh my bad. Oh my bad. So I think we can move the whole of this like that. Why is it still complaining? Oh yeah, it's supposed to be like that. All right, so that should be fixed. Yeah, perfect. So this works okay. And then if we get this back to, what was it? Was it? Yeah, it was 7. If we get it back to 7 and then we run it, they should give us a true. So that means this is working perfectly. And we have already explained why the better one is better than the naive one. Okay, so in the simplest possible way I can sort of elaborate this is, in the naive one, you're using 2 loops, all right, which means it's going to take twice the amount of time taken to find the answer than when you're using this better one. And you could only think about this better one if you have knowledge around data structures. You know what a set is, and you know how you could correlate this to this question. And that is not how you could correlate it to this question. And that is not something I can just dump on you. You need to be able to have had an understanding of data structures in depth. So I think that would be it from my end, unless we have a question. Any questions on this specific issue, or this specific question on how we have solved it, or any other question correlated to data structures and algorithms? I think I'm open for that. And in the meantime, I could take back the session to Madam Grace. So I'll stop sharing my screen.
All right, guys, do you have any questions? Feel free to unmute or put the question on chat. In the meantime, I will paste the links to our community channel, and as I wait for the questions to come in, I will shortly tell you about our upcoming data structures and algorithms course. It is among one of our short courses that we offer. Next cohort is coming in on June 2nd. It is a 10-week course that's starting on June 2nd. From week 1, you're going to learn about foundational algorithms. That is week 1 and 2. Week 3 to 4, you'll be learning about linear data structures. Week 5 to 7, you will learn divide and conquer algorithms. Week 8 to 10, you'll be learning dynamic data structures. And then at the very end, we have a partner called Career Kickstart that will be doing soft skills, that is reviewing your CV and also your LinkedIn and helping you with branding. And finally, we'll culminate the program with mock technical interviews. We normally invite, recruiters for this last session. So you're getting so much value for less. Currently, the early bird is on and it's only 3,000 Kenya shillings. I mean, that's a steal for 10-week course. That's very affordable, I would say. So I'm going to put the link on chat. If you're interested, be sure to sign up For those who had grabbed themselves a discount, I have sent you an email. Um, be on the lookout on your bell box. You should get the link to your redeem your discount. So I'm not sure if we have any questions on chat. I can't see any questions. Anyone with a question before we wrap it up? I know we are way past our time. Anyone with a question? I don't want to lock you out. All right. Being that nobody has a question, be sure to click on that link. I will also send a post webinar email with the link. And for those who joined late, I will be sharing the recording as well in case you missed the beginning of the session. Other than that, thank you so much, Charlie, for taking us through this session. And thank you to everyone who spent their time to join the webinar. Looking forward to see all of you in our DSA course. There's so much for you to learn, and there's so much for you to upskill on, not just on the technical bit, but also on the soft skill bit. That was it from us tonight. Have a lovely night.
Bye, everyone.
Bye. Thank you, Crispinas. You've gotten your email. Dope. Be sure to redeem your discount. Bye, everyone.